the x-intercepts are the zeros of our individual factors. We have x-intercepts at -3, 1, and 3. Now, how do we find the y-intercept without doing a whole lot of calculation or using our graphing calculator? Well, the y-intercept is the constant term for this one if we wrote it in general form. So it's going to be 2 times -3 times 3 times -1. So we have 9. We have positive 18. So we have a y-intercept of 18, a x-intercept of -3, 1, and 3. And we can kind of see that. That makes sense. -3, got to be looking like that because it's a third degree positive leading coefficient crossing at -3, 1, and 3. So that 18 makes sense. Alexis, what is 2p of x? What's the transformation applied to 2p of x? Vertical translation, vertical stretch, by how much? 2 or 1/2? So if I'm vertically stretching this by a factor of 2, my x-intercepts are going to stay the same. Not doing anything to the horizontal. The y-intercept will be twice as far away from the x-axis as before. So will every other point, but the only point that we cared about here was the y-intercept, or sorry, the y-intercept. Chloe, what did I do with p of 2 of x? By what factor? By 1/2. Okay. So my y-intercept is going to stay at 18. Because all I'm doing is this. My x-intercepts are going to be -1.5, 0.5, and positive 1.5. Because I'm multiplying each by 1/2. Sean, p of x plus 3. Three left. So that means my x-intercept is going to be 3 units farther left. So I'm going to have a -6, a -2, and a 0. Which allows me to figure out, do I get a new y-intercept out of this too? Because I picked up the entire graph and I moved it that way. So I'm going to have a new y-intercept. And in this case, the y-intercept is going to be 0. And because we could do this without any calculations because I have a new x-intercept of 0. So my new graph will be crossing. Nope, that's definitely not right. My new graph will be crossing like that. If it wasn't, in this case, if I hadn't given you that x-intercept being 0, you would have had to take in 0, plug it into, or actually what I would have done is I would have taken 3 and plugged it into here and see what came out. Because I knew it was 3 to the left. So the the new y-intercept would have started 3 to the right where we ended up. Now we have our understanding of polynomials and our understanding of transformations. I gave you a lot to do here. Now, this is the points. It's just like any graph that we're going to work with. Rory, give me one transformation.
Transformation.
Transformation is it's the whole category, not translation, transformation.
Okay. It is being flipped over the x-axis.
Reflection in the x-axis. What else do we do? Derek. Horizontal stretch by 1/4. Ashley? Vertical stretch is 2. Karen, what are the 2 moves that we do here? One right, 3 out. So all I'm going to do with this is I'm going to take these points and I'm going to apply the transformation. Now I'm going to combine them a little bit. I'm going to talk about the vertical reflection and the vertical stretch at the same time. So we're going to have 2 positive 16. Change the sign, multiply by 2. Sorry, negative 2. Negative 1, positive 2. 0, 0 stays the same. We have 1, negative 2, and 2, negative 16. So I'm multiplying by negative 2 is essentially what I'm doing. My horizontal stretch is the next one that I'm going to do. Lovely. Negative 0.5. Negative 0.25. 0, 0. So multiply every x coordinate by 1/2, or sorry, by 1/4. And then finally, I'm just going to do down here because I want to give my sketch a place to work. I'm going to 1 right, 3 up. So 1 right would be 0.5 and 19. 0.75 and 5. 1 and 3. And then I'm at 1.25 and 5 and 1.5 and that should be a negative. And then we would plot those, but since I don't have any grid on here, I'm just going to sketch it. So again, that's a sketch. So plotting polynomials is no different than if we were to Oh, did I? Hey, I forgot to do that. You're right. moved it over, didn't move it up. So I have positive 1, and I'm going to have negative 13. Any questions? So let's go over some word problems now. Three consecutive integers have a product of negative 210. Write a polynomial function to model this, and what are the three integers? Now, you can do trial and error, but I really don't want to. How would you write, if I said, x is going to be equal to an integer. How would you write down a consecutive integer? Yes? So, x plus 1 and x plus 2 would be the next two consecutive integers. Now, we talked about product. So, this equation is going to be x plus 1, x plus 2. That's a polynomial that we could use to solve this. How do we solve this? Well, I'm going to take my negative 210. I'm going to do that. Now I'm going to solve this. Oh, it better work. Okay, consecutive, so in a row. Negative 3, negative 4, negative 5. Graphically, I can plug this into a calculator and I can figure it out. Maybe I'll do that in a minute. But how would you solve this type of question using algebra? Well, if this was x plus 1 times x plus 2 is equal to 210, you would have to multiply the right-hand side and factor. And we're going to do the same thing here. Now, what I just did there is I multiplied x plus 1 by x plus 2 and then wrote x in front of every term. So we have 0 is equal to x cubed plus 3x squared plus 2x plus 210. Now, we could do the factors of 210. Probably going to start with looking at 5, 6, and 7. So does 5 actually, I'm going to go negative 5. Does q at negative 5 make this guy equal to 0? Now, why did I choose negative 5? because I knew 1 isn't going to work. Because it can't be -1, -2, -3. That's not going to work. -5, -6, -7 might work. Actually, I know it does. But my question is not 5 isn't going to work for this one. Does 5 give you -5 give you 0? How about Q at -7? Sean? Okay. Q at -7 gives you 0. Now I don't have to factor anymore. I could. Okay. One solution is -7. So your 3 consecutive integers are -7, -6, and -5. What is the solution, or what is, well, in this case it's only 1. What is the solution to this equation? Q at -7. Should be the only solution for that one. Okay. Now, as I said, you can go ahead and punch this into your calculator and find out -7 is your answer. We solved for x. We found the remaining 2 consecutive integers by just adding 1 to each of them. Don't need to factor anything on that. Now this one, as you can probably tell, came from a diploma. Or I came from an old diploma, but I have seen it on the new diploma. A box with no lid is made by cutting 4 squares of side length x from each corner of a rectangular 10 by 20 sheet metal. How do you get, how do we get volume? Because we're looking for the maximum volume. How do we get volume? Volume of a box is length times width times height. So we're going to cut x out of each side. So this side length would be 20 minus 2x, because it loses an x from each end. This here, so that's from there to there. I'm going to fold it up at that point. This one here is going to be 10 minus 2x. And how high is my box going to be? X units. Okay. So volume is going to be height, which is x. Length, which is 20 minus 2x. And 10 minus 2x is my width. Maximum volume. If this was a quadratic, we could find maximum by completing the square. But we don't have that ability in this case. So this becomes, once we've got the equation, this becomes a calculator question. And I don't need to, and I would not expand upon this. Oh, there's my equation. Before, because I'm not going to get anything if I go zoom 6. If I just hit graph now, that doesn't look very good. Okay. Let's talk about the problem. What's the minimum amount that you can cut out of that box? What's the minimum amount you can cut out of that box? 0. And I have a flat thing and I have no box. What's the maximum side of my cutout X that I can cut out? Now, if I cut out 10 of this, I'm cutting out the side. Your right idea, you took half of that guy, but you need to look at the smaller side. The absolute maximum is 4.999 repeated to get a box. So what I'm going to do there is I know my minimum X value is 0. My minimum or my maximum X value is going to be 5. I'm going to go to my windows, 0 to 5. And once you have that, because I don't know exactly what my maximum Y value is going to be. So I'm going to go to Zoom. I believe I have a Zoom Fit down here. I know you guys do. I'm going to go to Zoom Fit. What that does, it tells your calculator to give me all of the values for Y that are within that 0 to 5. And I get a nice looking graph that looks like that. Now, how do I find the maximum point on the graph? Second trace. I want my maximum point. Move my spider to the right of my, or left of my maximum. My spider goes to the right of my maximum. So I have lines drawn, but you're between those 2 points and hit enter. So my maximum volume is 192.5 cubic centimeters. When I cut out 2.1 out of each side. There is no algebraic way to solve this one yet. There's a calculus way to solve this later on, but there's no algebraic way to solve this right now.
Imagine I could jump.
So there's the answer to your question. So our graphing skills, our calculator skills that we used last year are going to be or could be tested. Yes. Any questions on this? So maximum volume 192.5 cubic centimeters when a 2.1 centimeter cutout is used. So generally what you had here is you had to be able to get that question and then use the graphing calculator to solve that question. You have 7 questions to do. I would like you to try 20. It's a bonus question, but it should be doable for all of you.